All right, welcome to 3.1, Solving Linear Systems by Graphing. Today we're going to gain the power to solve a system of equations with two variables by graphing. So let's give a little bit of definitions for us. System of linear equations is going to read is two or more equations solved all together at once. So I can have more than one equation. I can solve them together, and I'm going to come up with a solution to those. So two or more equations solved all together at once. A solution of a system of linear equations, well, there's going to be three types. And remember, a solution means an answer, right? We get an answer. There are going to be three types of solutions for a system of linear equations. The first one is one solution, i.e. just an xy. So I'm going to get an ordered pair, I'm going to get an x, I'm going to get y to be equal number. That's going to be a one solution. The next one is a no solution, i.e. 3 does not equal 4. So if you come up with a answer that has 6 equals 7, well, we know that 6 does not equal 7. So that is going to give us a no solution. And the last one, the third solution, would be infinite many solutions, sometimes commonly referred to as this symbol. I would take that, or you could use IMS for infinite many solutions. But the bottom line is you come up with an equation like the answer 3 equals 3. So if I have a system of linear equations and I come up with 3 equals 3, then I know that I'm going to have a infinite many solutions, i.e. it's just going to be one line. Okay? If you need to write down these definitions, please do so. You can pause and do that. Remember that you can pause these videos at any time. All right, I'm going to move on. Here we go. So let's get our brains warmed up and start thinking about what we're going to be doing. And so I want to evaluate each expression for when x is equal to 1 and y is equal to -3. So what does that mean? Well, I'm going to think about input and output, and I want to substitute in 1 in for this x, and I'm going to substitute -3 in for this y. And so as I do this, I see I'm going to substitute 1 in minus 4 times that -3. And I'm going to think about what is that? Well, that's 1. A -4 times a -3 becomes a positive 12. I know that 1 plus 12 is 13. So I've evaluated this expression for when x is equal to 1 and y is equal to -3. And that comes up with 13 as my solution to this. Okay? Let's do another one to get our brains warmed up. I'm going to substitute this time a 1 in for this x, so I'm going to do this one, and then I'm going to look at it, and I'm going to substitute this -3 in for this y, and I'm going to solve that expression. So when I look at this, this is going to be a -2. It is going to be times by 1, and that's going to be added to a -3. Okay? And so I look at that and I go, -2 times 1, well, that's a -2. I still have a plus, and that's a plus a -3. Well, -2 plus a -3 is -5. So my answer to that one, my solution is going to be a -5. Okay? Moving on. The next one. It says, find an ordered pair that is a solution to when I have two different equations here. I have the first one, which is y equals x plus 1. And then my second one is going to be y equals 5 minus x. So these are my two equations at this point. And the instruction says find an ordered pair that is a solution to it. So basically what is it saying to me is that I am going to find where I have an input and output that are going to be matching. They're going to be both for the same one. Okay? So on this, I really want to think about input and output. What can I input into the equation and what can I get output? Well, when I think about input and output, I think about setting a table, making a table. and that's my input and output table, which is an x and y. Remember that always goes with our domain and range, and it also corresponds with a point on a graph. And so in this one, I'm going to think about numbers, and let's say I'm going to start like number -1, I'll go 0, 1, and 2. And so those are the x values that I can plug in and solve for. So as I see this, I want to think about, okay, let's go ahead and plug a -1 in. So as I see and I look at it, I've got y equals, plug a -1 in for x, add it to 1. Well, that's going to come up with 0. So I know when x is -1, y is going to be 0. If I plug a 0 in, that's y equals 0 plus 1. So I know I'm going to be equal to 1. And I'm going to do this for all 4 of these numbers, for x being -1, x being 0, 1, and 2. So if x is 1, y is going to be 2. And when x is 2, y is going to be 3. So I've come up with a little input-output table for this equation. Well, I need to turn around and do the same thing for this one. So I'm going to go ahead and set it up, little x, y table. I'm going to think about, let's choose the same numbers, and let's see if we come up with a solution that's going to be in this table and in this table. So the first one, I have y equals 5 minus x. So this becomes y equals 5 minus -1. Well, 5 minus a -1 is 6. So I know that when x is -1, y is 6. Well, I'm going to do the same thing for all 4. Y equals 5 minus 0. So that just becomes 5. And I'll do the other 2 in my head. Y equals 5 minus 1. So that is 4. And then y equals 5 minus 2, which would become 3. And now to look at this, I want to see, is there a solution? Is there an input and output, an x and y ordered pair that is the same for both of these? Well, the answer is a quick and a resounding yes. I got a 2, 3 and a 2, 3. So my solution to these equations that is common between them is the ordered pair 2, 3. Okay? So I know that my x value 2, y value 3 is a solution that is common between both of those equations. All right. Of course, if you need to pause, go ahead and pause at this time, and we're going to keep moving on. All right. Is the ordered pair a solution to the systems of linear equations? Well, I'm given the solution 4, 1. And now we need to know if it is truly a solution or is it just a set of numbers, right? And once again, I want you to think about the idea of an input and output. Input and output. This time I'm given what I need to input, and I want to see, does the output equal what it's supposed to be equal to? So as I see this, I want to plug in 4, 1 into the first equation and 4, 1 into the second equation and determine whether or not it is a solution to this system right here. Okay, so the first one, use x plus 2y equals 6. So I'm going to plug in, and I'll do it in a different color. I'm going to plug in the value of 4 plus 2 times 1, because 1 going in for the y, equals to 6. So as I look at this, I've got a 4 plus 2 times 1, so 4 plus 2 equals 6. 4 plus 2 is 6. 6 does equal 6. So 4, 1 is for sure a solution to the first equation. My answer would be a yes for this one. But I don't know if it's a solution to the system yet because I haven't done the second equation yet. So I need to do that one. So I'll look at this and I'll go, okay, x minus y equals 3. Well, I need to plug in a 4 in for x minus, I'm plugging in a 1 in for y and set it equal to 3. Well, 4 minus 1 is 3, and 3 does equal 3. So my answer is yes to this one. And since I'm answering yes, and I'm going to circle this because I need to make sure I can prove it, this yes and this yes tells me that it is a solution not to only to one, but to both equations. Since I answered yes to both, it is the solution to this system of equations. All right, so as we're looking at this, let's do another one. Is the ordered pair a solution to the system of linear equations? And this time I'm given the point -1, 2, and then I have the equations 2x plus 5y equals 8 and 3x minus 2y equals 5. And I want to determine if that is a solution. Okay? So I'm going to go ahead and go ahead and rewrite my first equation. And I know that I want to use -1 for x. Looking at that. And then 5. And I want to plug in a 2 in for that. And I'm trying to do them in different colors so we can see where I'm plugging in the -1 in, the 2 in for y. Well, 2 times -1 is a -2, plus 5 times 2 is 10, equals 8. Well, -2 plus 10. Well, -2 plus 10 is 8. And 8 does equal 8, so my answer to this one is yes. It is a solution to the first one. But I don't know if it's a solution to the system yet because I need to do the second one. Alright, so the second equation is 3x minus 2y equals 5. And once again, I'm going to plug in some values in. So -1 in for x. So this is 3 times -1 minus 2. My y is 2, so I'm going to plug in 2, and then it's going to be equal to 5. Well, 3 times -1 is -3. -2 times 2 is -4, equals 5. Well, what is -3 minus 4? Well, that's the same thing as saying -3 plus -4 equals 5, and -3 plus -4 is a -7. But -7 does not add up to 5. So the answer is no on this one. And since I do not have yeses on both, I've got a yes here, but I've got a big resounding no here, then the answer is -1, 2 a solution to this system? Well, the answer is no. It's not. It's not a solution to this system of equations because we didn't come up with the same answer when we plugged them in. All right. Once again, if you need to pause, please do so. Get everything down, but we're going to keep moving on. All right, the next one. Now, we are going to be graphing to find our solutions, which means we need to know how to graph each line. So as we look at this, we're going to graph each one of these and then find out the solution, because where the two lines cross is our solution. So where the two lines cross is our solution. Well, if I look at the first one, I've got a y equals a -3x plus 2. Well, I'm in slope-intercept form. And if we remember correctly, slope-intercept form, basically what that tells me is that this -3 is my slope, and this 2 is my y-intercept. That is my y-intercept. So what does that tell me? Well, my y-intercept is a point where it crosses the y-axis. Well, my y-axis, where it crosses the y-axis, is right here. So I have a point 0,2 right on there. My slope is a -3. What that really means is my slope is a -3 over 1. So -3 over 1, so I can go down 3, 1, 2, 3 over 1. It gives me one of my points. And I can also do a point up above my original, and that means going up 3, but going over a -1. As I do that, I can go ahead and graph, draw my nice straight line, as straight as I can make it, and we're ready to go. Now the second one. The second one is a -6x plus 2y equals 4. Well, that's not in slope-intercept form. So I need to go ahead and put it in slope-intercept form. Well, slope-intercept form, you remember, is y equals with an x term on the right-hand side and a number on the right-hand side as well. So I want to go ahead and, what am I going to do? I'm going to add 6x to both sides. So I'm moving that negative 6x to the other side. How I do that is by adding. So that's going to leave me with a 2y equals 6x plus 4. As I'm here, I want y by itself, so I need to divide by 2, which means I'm going to divide every number by 2. So that's going to give me y equals 6 divided by 2 is 3. X is still there, and 4 divided by 2 is 2. So that gives me the y, or the slope-intercept of 3x plus 2. So as I look at this, I can see that my y-intercept is 2. I'm going to do this one in red. So I have that point right there. And then my slope is a positive 3, so I'm up 3, but I'm over a positive 1. I'm down 3 and over a negative 1, so I had to go negative, negative makes a positive. And I would graph my line. And it would look like that. It looked like that. Well, the key to this is my solution is where the two lines cross, where the two lines intersect. Well, they intersect right there. What is that point? That point is at 0, 2. So that is my solution. This is my solution, where the two lines intersect. Let's do another one. I've got a 3x plus 2y equals negative 4 and a y equals x plus 3. Well, I noticed between the two of them, one's already in slope-intercept form and one is not. Let's go ahead and deal with the one that is not. I have a 3x plus 2y equals a negative 4. Well, I want to go ahead and move my 3x to the other side. That gives me 2y equals negative 3x minus 4. I'm going to divide by 2, giving me y equals, that's a negative 3 has x minus 2. So as I look at this, I know my y-intercept is at a negative 2. My slope is a negative 3 halves. That's a negative 2 and a negative 3 halves. So my y-intercept being negative 2. Go ahead and plot that. That means the point 0, negative 2 is my y-intercept. And my slope is a negative 3 halves. Down 3, 1, 2, 3 over 2. Gives me a second point. Up 1, 2, 3. And since it is negative, since I went up 3, 1, 2, 3, I've got to go over a negative 2 to give me that point. And I'm going to leave them right there for a second. And I'm going to go ahead and plot. Now, let's go ahead and draw the line. We'll draw our line. We have 3 points. Make sure we get them as close as possible and straight as possible. Good job. All right. So my next one. My next line is y equals x plus 3. Well, that's in slope-intercept form, so I can go ahead and just graph this one. So my y-intercept is 3. My slope is, what's the number in front of the x? Well, the number in front of the x is a 1. And written as rise over run is 1 over 1. So I can go up 1 over 1. I can go down 1 over 1. And I can draw my line. Well, where these two meet, where these two cross, is my solution. Well, they meet at the point negative 2, 1. So my solution is going to be at negative 2, 1, where they meet. So this is my solution. All right. Got a couple more for you. Moving on. The next one is going to state y equals 1/5 x plus 3. In the second equation, it's 5y minus 2x plus 30. All right. Let's go ahead and get this one done. I'm in y-intercept form or slope-intercept form for the first one. we need to solve the second one. This is a 5y equals a negative 2x plus 30. I need to solve it. Well, the easiest way to solve it is just to divide by 5. I need the y by itself. So divide by 5, divide by 5, divide by 5. What I do to one side, I must do to the other. So this becomes y equals a negative 2/5 x plus 6. So that tells me that I can graph this at the y-intercept of positive 6. And my slope is a negative 2 over 5. Down to over 5. Where are you, 5? There you are. And I can go up 2 but left over 5. Up 2 over 5. And draw my line. Well, the next one, the first equation, is y equals 1/5 x plus 3. Well, that's in slope-intercept form. We can see that. So we can plot y-intercept of 0, 3. My slope, 1 over 5. 1 over 5. Down 1 over 5. I missed my line a little bit, but you're going to see where they cross. They cross right there. They cross right there. Let me do that in a different color so you can see it. They cross right at that 5, 4 mark. 5, 4 is going to be my solution. So as I see, my solution is going to be 5, 4. If I could draw a little bit better, my line would have gone right through that point. But they both have the point 5, 4. And so that is my solution, 5, 4. All right. Make sure that you can pause this and do some of these on your own as you're going through this. We've got one more that we're going to do, and then we're going to move on. I have negative x plus 3y equals negative 12, and negative x equals negative 6. Negative x equals negative 6. Well, let's go ahead and do the first one, and that is negative x plus 3y equals negative 12. Well, I'm going to move that x to the other side, leaving me 3y equals x minus 12. As I look at this, I know that I have to get the y by itself, so I must divide by 3, divide by 3, divide by 3. So y equals 1/3 x minus 4. So that tells me my y-intercept is at negative 4. And my slope is 1 over 3. So up 1 over 3. Down 1 over 3. I'll do that again. There. Up 1 over 3. And this time I might be able to get a straighter line. Give myself some more points to hit. And there we go. All right. The next one is negative x minus, or negative x equals negative 6. So negative x equals negative 6. Well, that's interesting. I have no y. Well, that's right. X equals a number is a vertical line. I'm glad that you were thinking that. But I have a negative x. I don't have just x by itself. So I must divide by negative 1. Must divide by negative 1. So x is equal to positive 6. You are correct in your thought, and that is this is a vertical line going through the point 6. If you weren't thinking that, this is one of those that you have to start just memorizing. That x equals a number is a vertical line. Well, where those two lines cross, where they intersect, is my solution. Well, in this case, it happens to be at 6, negative 2. So 6, negative 2 is my solution. Solution to this system is at the point 6, negative 2. Try the last one on your own. We'll see you in class. Ask any questions that you have. Happy to answer them.